Hello, Professor George. This is Michael Freitag, and this is my presentation for my vending machine project for ITSE 2331 Advanced C++ Programming. So to begin here, I'm going to go ahead and go into Visual Studio, and I'm going to go ahead and compile and run my code and first show you how the program works. So basically, my goal here was to simulate the operation of a vending machine, which includes the ability to come to the machine and as a customer buy something from the machine. But I also considered that the vending machine has somebody who owns and operates it, and who needs administrative functions in order to do so. So I also have an administrative function built into the program as well. So basically, in order to use the program, we see here that we have our vending machine main menu item. Vending machine main menu title, and the user is presented with a couple of menu options here. They have two menu options. One is to select an item for purchase, and the other is administrative menu, and of course the other one is just to quit the program. So if this was an actual real vending machine, the user wouldn't of course have access to the administrative functions of the machine so easily, but since there's no GUI and this is not a real vending machine, it is what it is. So I'm going to go ahead and go into the option 1 to select an item for purchase, and I'm going to be presented with the sales menu, and I can see that this machine has Twix bars, root beer, Hershey's, Cokes, and I can see the prices for each of those items. So I'm going to go ahead and decide to buy a root beer for $1.50, so I'm going to hit selection 1. And I'm being prompted here to either use coin, cash, or credit card. So what I'm going to do is go ahead and select coin, and I'm being prompted just like a real machine if I was putting in nickels, dimes, and quarters, how many nickels. So I'm going to say I'm going to put in 10 nickels, I'm going to say I'm going to put in 10 dimes, and I'll go ahead and say I'm going to put in 5 quarters. So we see here that I inserted $2.75, my change is $1.25, and I'm told thank you, enjoy your root beer. And I just successfully made a purchase from the machine. Now, there's some logic here. So let's say I were to come to the machine just like a real person could do on a real vending machine, and I want to buy this Twix bar for $2.25, and let's say I don't put in enough money, so I go to coin, and let's say I want to put in 1 nickel, 1 dime, and 1 quarter. Of course, that is not enough money to buy the Twix bar for $2.25. So I'm told here you insert insufficient coins, your money is being returned, and to try again. So I can go ahead and try again. I'm going to put in 10 nickels. I'm going to put in 7 dimes, I'm going to put in 7 quarters, and I see now that I put in $2.95 and I got 70 cents back, and I got my Twix bar. I can also go into the sales menu, and I can say, I want to buy a Pepsi, and I can choose to use a credit card. So just like some vending machines take credit cards, so does my program. Obviously, credit cards are exact change, so I completed the sale at that point. It's assumed I swiped the card. And that is how you can make purchases from this vending machine. So basically, I also have an administrative menu, which is option 2. This controls all the administrative functions of the machine. So that's the item stock, the prices of the items, the names of the items, the values as to how much money the machine's collected in total. So let's say I want to reset. Let's say I just came to the machine and I filled it up. I can hit option 2 to reset all item stock to max, which is 20 units for each item. And I'm told that all item quantities have been set to 20, so the machine is now fully stocked. So basically that's done. I can change individual item stock if I want to, so I can hit option 3, and maybe I don't have 20 root beers in the machine, so I want to hit number 1, and I'm going to change the quantity to 10 root beers. Now the machine knows that there's 10 root beers, so if the machine is out of stock, the user will be advised of that. So let's give an example of that. Let's go ahead and go back to option 3, and let's go ahead and change root beer to 0. Let's say it's out of stock. So now the machine knows it's out of stock. I can go back and I can go to the purchase menu and I can hit root beer, and the customer is told, sorry, this item is out of stock, and to select another item. It doesn't take their money because it knows it's out of stock. So I'm going to go ahead and go back to my administrator menu. I can also reset collected money balances. So if I want to reset the amount of money the machine's collected, I can do that. I can enable or disable accepted tender types. So maybe this machine doesn't take credit cards. I can enable it to accept coins. I can enable it to accept cash, and I can disable credit cards. And those tender types that the machine accepts are now set. I can also name and rename items. So let's say, here I have a root beer is, well, let's say a Twix is item 0. Let's say it's actually not a Twix anymore. Let's say I'm changing that to, let's say a water. So it's just a water bottle. I can rename it to water, and now I know that that item there is water. I can also change item prices. So now that I've changed it to water, maybe I want to change the price from $2.25. So I'm going to set a new price of $1.95, let's say, and that's the new price for that item. So that's basically how the administrator menu operates. I can go ahead and generate a detail report, which is item number 8 here. And this is a full detail of the vending machine. So I can see, all my item names. I can see my item inventories. I can see my item prices. I can see how much the machine has collected in coins, cash, and card individually. And I can also see the grand total that's been collected by the machine. And I can also see what tender options are accepted by the machine here. And that is the administrative menu. So what I'm going to do is, you probably noticed that there was some data in there as far as the item names, the quantities, all that was in there. And I'm going to go ahead and go to my folder over here, which is at C:\vending. That's my vending folder. And you'll see here that I have some files. These are just test files that I was creating just to have some of this set up for the presentation. But the actual file that's being read and written by the program is this vend1.txt file here. So if I go into this, we can go ahead, we can go ahead and see that I have some data in this file. Here we can see 20, 0, 2020. We can see some item names here. We can see some values here, $1.95, 1.5. None of this is really, this is obviously not for user view. This is just for me as a developer to read and write from, and it's formatted into a specific format. So I'm going to get into how this is done when I go into my code, which I will go ahead and go into now and start talking about. So basically, this is the program in Visual Studio. Basically, I have my main function here, which is, of course, where the program begins. And all I have in main, actually, is I have, basically, I'm referencing a class that I wrote, which is a vending machine class. And I'm creating instantiating an object from that class called myMachine. And then once I instantiate the object, I'm referencing from that object the vending main menu function, which is a function in the class. So let's go ahead and look at the class here. So, before we just get into the class, which is right here, basically I have header files here. So, I'm including the IO stream header because I'm doing cout and cin operations. I have the fstream header file for file read and write. I have my IO manipulation header file, which I'm because I'm doing some IO manipulation, which we did in our first C++ class. I'm actually using some of that knowledge in the program. So all those headers are there. We have our standard namespace, and now here is the class. So we have our vending machine class. So in the vending machine class, I have only two things are public in the vending machine class. So in other words, as the developer, this is what I can directly call from outside of the class, or as an object of the class I created. So I have my vending machine constructor, and I have my vending machine main menu. So let me go ahead and talk about the constructor first. So in the constructor, I basically am calling two functions, or I can call two functions. I'm basically doing a little test here. Now, all of these functions I could have written these in the constructor itself. I decided not to do that, just to keep the constructor because it would be a lot of code, so I just kept the constructor a little clean looking. So basically what I'm doing here is I'm doing a logical test with this if block, and you'll notice I'm calling the read data file function in the class, and I'm doing a test to see whether or not this read data file function returns a value of true. So most of my functions in the program are actually void, which means they're not returning anything. However, this function is actually returning a Boolean, true or false. So what I'm going to do is go ahead and go to the read data file function, which should be down here. Okay, so here my read data file function is. So you'll notice, it is, I do say bool read data file. So in other words, this function is not void. It is returning a Boolean value to whatever calls it, which in this case is my constructor. So basically here I've declared a bool variable called read status. I'm setting that to false, and I'm instantiating an object from the IF stream, a vending data file, which I'm calling vending data file read. And here I'm calling vending data file read, and I'm calling this function open from it, and I'm testing here to see whether or not the file, my C drive vending folder, vend1txt file exists, which is the file over here I was just talking about. So if this file does exist and it can be opened, then this logic block right here, which is testing for that, will execute. However, if the vending file does not exist, and let's go ahead and test that and see what happens here. So I'm going to go ahead and call this vending1old, so that the file no longer exists. And I'm going to go ahead and run the program really fast. And I just ran the program, and I'm going to go ahead and close it at that point. Because, again, we were already in the constructor, and the constructor called this function. And you'll notice now that the vend1txt file is back. The reason is it didn't exist. And what happened now is you'll notice I've got the vend1txt file, and I've got, the similar data arrangement here, but the values are somewhat different. All my item names are gone. There's called item. All my unique prices are just $1.55. These are zeros and ones right here, set to default. So basically all these are set to default values. And the reason that happened is the vend1txt file did not exist. So when this was tested, it did not exist. So what happened is all this code was skipped, and I just returned back to the constructor the read status Boolean, which was false. So if the read status Boolean is false, we can go back to the constructor, and we can see here that if it returns false, if it does not return true, then this block right here executes, which is just calling a function called generate default vending memory data. So I'm going to go ahead and look at that function. Now this is a function that basically triggers if the vending file does not exist for whatever reason. Maybe it's the first time the vending machine is used, and it needs some kind of values for the vending machine's memory. So that is going to go ahead and be called and set the memory values of the machine. So before we look at that, let's look at the vending machine memory. So we're going to go ahead and go into my the private part of my class, which is right here. And these arrays right here that I'm declaring are the memory of the machine, of the object. So any vending machine object is, of course, going to have its own memory. So, I could, in theory, modify this program slightly and instantiate more vending machine objects. So I could have maybe multiple vending machine objects running at once. And I considered doing that, but it kind of goes beyond the scope of the project, so I didn't do that. But, these are all unique to the vending machine object. So basically, let's look at this. I have 5 arrays here, and I've named them, to conveniently, good names so I know what they are. I see here that I'm declaring an array that contains integers called vending memory item counts, which has 15 elements. So, of course, this array is containing the quantity of items, so how many of each item are in the machine. I have a string array, which is the vending memory item names, and I have a float array, which is the vending memory item prices. So these first 3 are parallel arrays, so there's a logical relationship between the elements in the array and the arrays themselves. So the element at position 0 has a logical relationship among all 3 of the arrays. The element at position 1 has a logical relationship, and so forth. So here I also have another array, floating point array. Float array. So basically, I'm storing money collected here, and then I have a Boolean array, which is containing toggles. So Booleans that indicate whether or not the machine takes card, cash, or credit card. And as far as what these elements in the arrays actually, what the elements actually, where the elements are in the array matters. So basically, before I wrote any of this, I came up with this this little diagram here, where I mapped out where the memory, where the what will be stored at the specific element index, what we stored at the specific index locations in the arrays. So, for example, in my money collected array, collected array right here, I know that the element at position 0 contains coins, the element at position 1 contains cash, the element at position 2 contains card, and the element at position 3 is the grand total, stores in that element the grand total that the whole machine has collected in sales. And the same thing I have mapped for all the elements in all my arrays, so I know I can look at this key and I know, okay, that's what I'm storing at that particular position in these arrays. So anyway, we can go ahead and go back to the generate default vending memory data. So if the data file does not exist, what I'm doing is going ahead and I am setting in the arrays default values. I'm doing that in my for loops. So in my parallel arrays, I'm going ahead and iterating through all three of the arrays at once, and I'm setting them to default values, so 20 for item counts, 1.55 for item prices, and item for the item name. And then I'm going through my remaining two arrays in their own unique for loops and setting default values there. And then you'll notice that I'm calling a function called write data file. And I call this a lot whenever I make, in my program, whenever I make any kind of changes to the arrays, at the end of that operation, I'm calling the write data file, so that what is in active memory and what's in RAM in the program is, in the machine, is written to the disk as well. So if the machine, I'm just pretending, if the machine were to need to be turned on and off, it would be able to retrieve from disk what should be in memory. So I'm going to go ahead and look at the write data file function, which is down here. So basically what I'm doing is, if we go back to the data file here, we go to ven1txt, what I'm doing is I'm declaring over here in my code from the OF stream an object called vending data file write, and I'm going ahead and I'm referencing the path and the name of the vending file, and I'm iterating through each array individually. And the reason is these are all being streamed into the ven1txt file, and they have to be in a certain order for this to logically make sense as the program operates. So I'm going through the first array and I'm writing all these 20s here, and then because that's what's in memory when that constructor does not find the file. And I'm going into the second array, I'm writing the item names, which are all in whatever's in memory, because this function writes whatever isn't stored in those at any given time, and so on. So basically the booleans are written down here, the money collected is written in these right here in the file. So basically that's how the write data file function works. But then whenever I need to read it, which is only if the file exists and when at the time the program is run, so in other words, that's how the program was able to load all this data. So the correct item names, the correct item prices, and I'm going to go ahead and just for the sake of this presentation, delete this one and go back to that one, so we have that to work with. So if the file does exist, then my constructor goes ahead and gets a true value from this, and none of the the default function is never called to set default values, and all this is read into memory. Now, as far as I know on this project, on this presentation, I'm supposed to talk about also some issues that came up, and I definitely had an issue with this function, unlike my write function. And you'll notice here that I kind of wrote a comment to you, but basically this function works. This function works in much the same way that the write data file function works, except here, because in our textbook it talks about how when we're using CN and we're using getLine, CN has an issue when it encounters white space characters. So in order to support the ability for the administrator to use item names that have spaces or white space in them, I had to switch on this for loop right here to using getLine. The problem is when I did that, now I was doing basically I was using my extraction operator to feed into the item counts array, and I was doing that for my other arrays too. But when I tried doing that here, and you see I commented out that line just to show you, when I tried doing that, what had happened is I got basically what appeared to me to be an off by one situation, in which the very first item or very first element that was written in this to the array in this for loop was white space. And I think what had happened is basically our textbook talks about how there's white space in the keyboard buffer or in the buffer, and when you're using getLine, it's going to capture that from when the user last hit enter, for example, and put in a new line character, the \n character, or that ASCII code. So what I tried doing is I tried doing a a getLine ignore statement here, and that did not work. Or I'm sorry, a CN ignore here. I tried that, and the program basically hanged at that point. Normally that would work, I know, if we were getting like a typed input, but it did not work here. So I figured what I needed to do was I knew that \n or that white space was there, and I needed to bypass it. So basically I just declared a string that I just called dummy, and I'm just assuming it's dummy data, which it is for my purposes, and I basically getLine it, and I just throw it into the dummy string, and then that eliminates that off by one error, and this for loop continues to read the file correctly using the getLine function here. And basically I'm able to handle when those white space names are encountered in the file, and they're put into the array correctly. And the delimiter here in the data file, of course, my delimiter is the new line character. I could have used a delimiter like to separate this data, like a comma or whatever, anything I wanted to. But of course, since these functions, from what I've read and research in our textbook, and also on Google, just use the new line character as a delimiter. That's what I stuck with. And then the rest of the function works just like the write function, no problem. And that is how the read and write data file functions work. So basically, let's go into the rest of the program at this point. So let's just step through it, I suppose. So here we go, and I have, let's say I want to select an item for purchase. I actually have two functions for that. So basically, we have the main menu, which is what's called to begin with. So there we go. So this is my main menu function, which is called for main once the object is instantiated. So here, basically, the way this works is, and all my menus work really, is I have a while loop, and the while loop runs until either a correct value is entered or the user wants to step back. So in this case, this loop runs as long as 3 is not entered, which is basically quitting the program at that point. And then what I did is in this menu, I created a switch statement. So, like in .NET, in Visual Basic .NET, it would be a select statement. In C++, of course, it's a switch statement. And basically, I'm just, since I'm just selecting some integer values on the menu, this looks nicer than an if-else or else-if block. So I just went with the switch statement here. And so if the user selects case 1, we're into the item purchase menu function. So I'm going to go ahead and go to that. So basically I'm using, in these functions, just to keep the text looking nice, I'm using the CLS shell or system command, which basically system is just passing into the shell, so like the terminal, a command. In the .NET languages, I think we would use the method shell here, but in C++ it's system. This is fine since I'm using Windows and CLS is recognized in Windows. If this was like a Linux program, which when I was using my web compiler is apparently running on Linux, this causes a problem because this command is not recognized. But since this is running on Windows, this is fine. This clears the screen, just keeps things looking nice. And I use this sporadically through my program whenever it makes things look nice. So basically, in the item purchase menu, I declare an integer and a boolean. The integer is the user menu selection, so I'm storing that there. And then the boolean is just to make sure, it's a logical test just to make sure input is valid. And I'm doing a while loop here. So basically, as long as the user is not selecting 15, which is to go back, or the input valid flag is false, this is running. So basically what I do is I draw up to the user using cout. I iterate through the item names array and the item prices array to display that to the screen. That's displayed to the screen. So when we go here and we hit item 1, this code right here is iterating, and this is all drawn up to the screen. The user, this is an if block here to make sure that the user is selecting a valid selection. And also I'm doing a little test here. So what I'm doing is in this test right here, I'm just making sure that whatever the user selects is not out of stock. And the way I do that is I have my vending item counts array, and I'm just subtracting 1 for it and testing to make sure it's not less than 0. Because if the user selects an item and the value is less than 0 when 1 is subtracted from it, then logically I know that that item is out of stock, and that stops the whole thing. Here the user is told that the item's out of stock and nothing else happens. They just need to select another item. And I'm putting a system pause. Again, I'm using that just like my CLS statement. Just to pause terminal output, so the user is told, press any key to continue, just to keep things under control for the user. So if the item is in stock, though, we do another test. So basically I'm testing here just to make sure that the user also selected a valid menu selection. So that's 0 to 14 here, or 15, which is right here. This is the test for 15. Those are all my logical tests going on here. So if the user does select a valid item and it's in stock, you can see right here I'm calling another function called make sale, and I'm passing into that function an integer value, which is the user menu selection. And this is why using the parallel arrays is so important, because there's a logical relationship. So all I need is the integer value of what item we're dealing with here. And whenever I work in the arrays, I'm in the right index value for all three item characteristics. So anyway, if everything's good, make sale is called, and the user selection, so like item 1, for example, is passed into that function. So we can go ahead and go to the user menu selection function, and that is not the user menu selection function. I'm sorry, I'm not the I mean the make sale function. I want to go to the make sale function. So here we are in the make sale function. And you can see that the way I wrote this is I wrote this function so that it does receive an integer as a parameter called selected item. So this receives that, and this handles the entire sale operation of the vending machine. So basically same setup as the menu. And most of my menus are set up like this, where I have my user menu selection integer, and I have my boolean to see if everything's good and it's a valid input. And basically, once this is called, so I hit 1 here, for example, to purchase that root beer. It's out of stock, so let's do Hershey. And you can see here that I'm in this function now, because I'm in the make sale function, and I'm being asked, how are you going to pay for it? And I have a logical test here to basically make sure that everything, a valid selection was made. So they chose, and because I have credit card disabled, that's not showing up here. And you can actually see here, this is where I'm writing that to the screen. So if the machine is set to accept these, then these are presented as options to the user. But if I'm testing my those elements, those Boolean values in that array to make sure they're true. If they are true, they're presented. But since I disabled credit card earlier, the user only has the option of coin and cash here. So basically, the user makes their selection for how they're going to pay. So if they choose coin, for example, we go into the coin block here in this if block, and I'm doing a compound logical test here to make sure that the user didn't put in unreasonable amounts of money. So in other words, I'm making sure they don't put in more than 100 nickels or a negative number of nickels, which obviously wouldn't make sense. Making sure they don't put in more than 50 dimes, make sure they don't put in more than 20 quarters. In this logical test right here. If they do, then the user is told they input invalid values, and then you do it again. Now here, if everything's good and the user did input sufficient money, if the user did put in valid money, but they didn't put in enough, I'm doing just some math here. So, order of operations applies in C++, just like in mathematics. So I'm doing I'm doing a multiplication here, nickels times 0.05, dimes times 0.10, and quarters times 0.25, and then I'm summing all those together to get the total number of cents. So I'm just testing to make sure that the total number of cents is not less than the item price for that selected item right here in the vending memory item prices array. So again, because I got parallel arrays here, as long as I know the selected item, it's very easy for me to move through the arrays and call the or make the relationship between what item the user is currently dealing with right here and the program's dealing with. So if this is testing to make sure there was no insufficient coins entered, and then they have to try again. But if this is not true, if there is more money than the price of the item or equal money, then we go right here, and valid coins input is set to true. Everything's good to make the sale. So I'm concatenating some information here. I'm saying you inserted, and I'm concatenating the total money they put in, and I'm telling the user how much change they're going to get, which is just the total cents minus the item price, of course. So if the user puts in coins 10, 10, 5, let's say, this is right here what's going on right here in the program. And then what I'm doing also at the end of all these sales functions or these sales operations is I'm storing that in the item money collected arrays. So I'm storing coins, like I said, I'm storing coins at element index 0, and I'm storing the total amount at element index 3. So of course, when we're in the coin logic block, I'm adding that to the element 0 in my money collected. I'm also adding it to my grand total element. I'm doing the compound operator plus equal here to basically just take the item price and sum it and accumulate it into those index values in that array. If we go on here to cash, same thing. I'm still going to the total here, the total array, the total element at position 3, but now instead of position 0 for coin, I'm in position 1 for cash, so we know how much cash the machine's collected. And likewise over here in credit card, which is user menu selection 3 if they have that option this time. Basically, I'm in position 2 for credit card, and I'm still writing to position 3 to get the grand total stored. So that's how the whole sale operation takes place. And you'll see here that on the end of all of these, or at the end of these, at the end of this logic block, I'm writing data file. I'm calling write data file because these arrays have changed in memory. Now I'm just writing them to the data file. So that's how that code works. So I'm going to go ahead back here in my program, and I'm going to go back, and I'm going to go to my administrative menu now. So let's just take a look at how reset all item stock works. And this is actually a very simple function. So I'm going to go ahead and find that function really fast. Let me go ahead and find that. Okay, so reset item counts to 0 is my function, and this is a very simple function. If the user wants to set, administrator wants to set everything to 0, basically I just write through. Sorry. Basically, I just write through. I call this for loop. I wrote this for loop, and I call. I don't call this. Run the for loop, and I set all everything at memory item counts index values to 0, and then that completes that sets all item counts to 0, and the write data file is called, and that's the whole function. Same thing for setting it to max. Instead of setting it to 0, I'm setting it to 20, and that's that function. So that's selection 2 here, and then also I have view change individual item stock. So let me go ahead and change item. Let me go ahead and find that here. So I'm going to call item counts. Where is my function here? Let me see. Give me just a sec to find my function. I'm going to go into my. I'm going to look at my administrative menu here. So this is where all the administrative options are. So I can see. I forget what I named it actually. So reset. That's case 3 here. So that's my show item counts menu. So the way that works, if the administrator picks option 3 here, is I go to the show item counts menu, and basically I'm clearing the screen. I have my same variables that I mentioned previously, and I'm drawing up that menu. So we can go here to change individual item stock, and we can see that's drawn up, which is what's going on right here in this while loop. And same kind of logic basically. So basically the user makes a selection, and I'm calling that user menu selection here, and I'm calling another function called set item count, which is receiving the user menu selection. So I'm going to go ahead and into that, so the user made their selection, it's valid, so then we can go ahead and go into the set item count function, and this is a very simple function also. Let me go ahead and find that. Let's see here. Oops. Where is my set item count function? I have them all together. Let me find that. Set item name, set item price, set item count. Okay, so this is my set item count function. So basically here, same thing. I received that parameter into the function, and I'm just going here to, if everything was correct, you didn't put any crazy input in there, going to that array at that item index, which is the selection that was passed into this function, and I'm changing the value here on this statement in that array element, and then I'm just writing the data file again. The user's told that it's done, and that's it. So let me go ahead and go back. And all my other functions, to not necessarily be redundant here, they all operate the same way. I'm just every time anything is changed, the arrays are changed, the array elements are changed for the corresponding index, and the data is read into the file. So all these will function. Change item prices. They all function about the same way. The only thing that's really interesting beyond that is the generate detail report function. So let me go ahead and find that function. So the generate report function here is basically just a nice little report that the owner of the machine, the vending machine administrator, can see to get an idea of what's going on with the machine. They can see item names, item inventory, item prices, everything in a nice one little screen. They can see the money collected, like I mentioned before. So basically the way this works is that, I'm just using cout to write to the screen what tell the user this is a report. And then what I'm doing is I'm just iterating through the arrays, and I'm concatenating values into the screen. And this is where I'm using my I/O manipulation also to make things look nice. So I'm setting the width to like 10 here to 15 here as the cout statement is called. So this is a for loop going through all of my parallel arrays. So again, this is another benefit of using parallel arrays in this program. I have my vending memory item names, vending memory item counts, vending memory item prices, and I'm just streaming all this into cout. So I'm getting the item name, and as I go through all 15 elements, I'm just writing all that to the screen, which is all right here. So basically, this loop is going through and writing all this to the screen, whatever's stored in those elements. Then I go on here. This is not in a for loop. These arrays, it's just it was just easier just to write these out as just individual cout statements. So this is just writing out to the screen what's stored in the arrays for the money collected. And then this one I'm doing some conditional logic checking as far as what tender types the machine takes. So I'm going ahead here and I'm testing to see if the machine is set to accept coins, if it's not set to accept coins, and based on what those Boolean values are in that array. And this is just a logic block to say yes, it is, to display yes or no nicely to the user. Yes, it is able to accept it. No, it's not able to accept it. And write that to the screen. And that is the report for the machine. So that's basically most of the code that's going on here. As far as complications, like I was saying, the CN and COut with white space, or the CN with white space, was an issue in the reading of the file here, and it's basically that I had to think about that for a little bit to realize it was the same thing as if I was typing in information. It's the same thing as reading it in from the file. So the white space is still an issue, just as reading in from the file using the file stream operators. Same as if you were typing it in. Same thing to I actually had to do the CN ignore. Let me find that really fast. I'm going to stop the program here. Let me go ahead and find CN ignore, because I actually did have to use that when the user's typing in a name, and you can see it right here. I've called the CN ignore function just because there could be white space here, and I'm having used getLine, so I don't want getLine when the user is renaming an item in the rename item function. I don't want the user to, I don't want a problem if the user types in white space for an item name. So I'm using getLine here, whereas at many other points in my program I'm just using CN because I'm not dealing with white space. So that is basically the program. That's how it all came together. That's how it basically works. The data file, can be, is always available. So all this is stored in real time. Whenever something changes, the vending machine keeps track of it all. So this kind of eliminates problems. Vending machines in real life, sometimes they don't know if they're out of stock on an item, and it may be that the program's not written to handle the item counts or store the item counts, or it's not storing them correctly. So sometimes oh, the vending machine stole my money because I selected a Coke and it never came out. So I think that this program would work really well if it was running on a real vending machine. I don't think there's any logical problems. It does a very good job keeping track of item counts. It does a very good job keeping track of money. One thing that did happen is I didn't have an array element for the total change that the machine has. So I was originally planning on doing that in my little mock-up that I wrote, but I didn't do it. So what I ended up doing, though, is I realized also that I didn't provide the administrator a way to change item prices. So I wrote the code for that in lieu of letting the administrator control the change that the machine has. But if this was like if I was going to do a version like 1.5 of this or version 2 of this program, and this was actually running on vending machines, that would probably be a new feature. I would probably add also an administrative option to allow for the change of the machine, how much change the machine has to make change for people to be controlled for. But this was a good semester project. I feel like I incorporated pretty much everything that I learned in C++. I've been doing .NET development as a hobby for a long time now. I was afraid of C++ when I started taking these classes, just because the syntax is very different than Visual Basic, and I also find the syntax to be less forgiving than Visual Basic. Like in Visual Basic, you can get away with implicit conversions, for example, whereas C++ is a little bit more strict. So, but I feel like I picked up the syntax pretty well. It's basically the same concept as Visual Basic. You got your loops, you got your variables, you got your arrays. It's an object-oriented language. And I feel like this is a good culmination of everything that I picked up in the C++ classes. And it works really well. So I really do like the C++ language, and I feel that this is, if I was going to do some GUI programming though, man, GUI versions, I would probably still use .NET. So like C# or Visual Basic. But for a console program or this was something running on a machine, a vending machine, a real one, absolutely this was a good learning experience. And that's about it. That's the program. I had a great time in this class. I feel like I learned a lot. I used a lot here. I used everything we learned. I think the loops. I used the variables. I used arrays. I used conditional logic. I used wrote a class and instantiated this as an object from it. So that's the program. Hopefully I did. I covered everything I wanted to on this presentation. This is actually take 2 of this because I didn't quite get it right the first time, which was a very long video. But thank you, Professor George. I hope that this covered everything, and I will submit my code in an executable to you, and that should be it. And thank you.